Hello, in this quick video, we will go over two things. A, what is the split bin problem? B, how to install and configure the Galera arbitrator. What is the split bin problem? Split bin happens when nodes in a cluster lose the communication with each other and each isolated group thinks that we are the real cluster. Let's say we have a two-node cluster and somehow a network connection breaks between them. So now the node A thinks I'm alone but I'm still alive, and node B also thinks the same. Now both the nodes start accepting writes independently. Eventually, when the network heals, we will have two conflicting versions of the same database. That's basically is the split bin problem. Essentially, leading us to conflicting writes and data inconsistency. How Galera resolves it? Galera, as we know, is a multi-master application, which means it's virtually synchronous. Unlike the traditional approach is to have a master-slave hierarchy, where a set of nodes act as master, we would be able to perform write operations over it, and other set of nodes act as slaves, so we can only perform read operations over those set of nodes. Unlike with Galera, each node in a cluster has equal rights and equal responsibilities. Galera resolves this split bin problem using a quorum-based voting system. The cluster only stays operational if the majority of the nodes agree that they are part of the same cluster. For example, let's say a 5-node cluster. So we have a 5 instances, node 1, node 2, node 3, node 4, and node 5. Let's say the node 4 and node 5, somehow the network breaks between them simultaneously and all the instance gets shut down. So we now have two groups. The group 1, which has 3 nodes, completely running fine. So the cluster remains operational because it's in majority, which means it can read and write. It can perform read and write operations. The other group, group 2, it's in minority. So basically they enter into a non-operational state. So the cluster waits until silently until they are reconnected. Why the two node clusters are basically problematic? If a one node fails in a two node cluster, we are only left with a one node. We don't have a majority. So Galera basically stalls everything. The solution for this is to either use an odd number of nodes, 3, 5, 7, etc., or in a two node or even number of cluster setup, use the Galera arbitrator. The Galera arbitrator, is just a lightweight daemon. Its role is to just participate in the quorum voting. It doesn't need to have MariaDB or MySQL installed. It doesn't need to store data as well. So with 2 DB nodes plus 1 arbitrator, if we got 3 votes. If 1 DB node goes down, the other plus the arbitrator can still maintain the quorum. The conclusion is that Galera says no group is allowed to make the decisions unless they are in the majority. And this prevents the conflicting truth, the split brain problem. The simple analogy is, imagine a meeting where decisions need majority vote. If 2 people are in the room, 1 leaves, so the 1 person can't decide, and the meeting stops. Similarly, if there are 3 people in the room, 1 leaves, 2 still have the majority and they can continue and decide safely. If 4 people are in the room, 2 leaves, or in the worst case scenario, we have 2 versus 2 split, so the meeting stops. Basically, the meeting stalls. Galera works exactly like this. It's better to have an odd number of voters or an arbitrator. Again, assume you have a 5-node cluster, node 1, node 2, node 3, node 4, and node 5. Let's say this time the node 1, node 2, and node 3 simultaneously go down. So what happens that now the node 4 and node 5 are in minority. As I've said it before, Galera works based on the quorum. A majority of consistent, connected nodes must be part of the primary component to allow the writes. So the result is the Galera stalls everything. Writes are paused and read or local select queries may still be possible depending on your configuration. For example, if you have enabled write set replication dirty reads, but it is generally discouraged. The idea is Galera basically stalls everything, and Galera cluster becomes unstable because it loses the majority. Similarly, if the two nodes shut down, now we have three nodes working simultaneously working, node 1, node 2 and node 3. So the three nodes are online and perfectly fine. The cluster works perfectly fine. The cluster stays completely operational. Therefore, the core idea behind this quorum voting is to avoid a split brain problem. In this demo, we are going to use the Galera arbitrator to avoid the cluster being non-operational in a two-node setup or in an even number of cluster setup. What we are going to do is just configure and install the arbitrator on the third node, as it just needs to participate in the voting system. So we would now install and configure the Galera arbitrator. The current setup overview is that we have three nodes, Zorin and Ubuntu 1 are already configured with the Galera cluster. So it's a two node setup, and Ubuntu 2 will become a Galera arbitrator. So let's first verify our current cluster status. So let me just sign up as a root user. I'm already signed up as. So accessing the MySQL as root user. Now we use the MySQL DB to get the list of the nodes connected within our Galera cluster. So we use MySQL DB and we will be querying the table right set replication cluster members to get the list of the nodes connected within this Galera cluster. Select from right set replication cluster members. As you can see that we currently have two nodes in a cluster. So this node 1 is a Zorin machine and Ubuntu 1 is node 2. Now the next step is to install the Galera arbitrator. So we are going to install the arbitrator on Ubuntu 2. We don't require MySQL or MariaDB installation, as arbitrator is just a lightweight daemon and its role is to participate in the quorum voting system. First, we update the packages and then we install the Galera arbitrator. Packages are already updated. Apt install Galera arbitrator. So it's installed. The next step is to create a Galera arbitrator daemon configuration file. So let me create it. Nano etc Galera arbitrator daemon configuration file. First, we have to specify the name of this Galera cluster, which is Galera cluster. Then we have to specify the address, the IP addresses of the machines which are connected to this Galera cluster. So let me verify the IP addresses. So the Zorin is connected to 192.168.207.139 and the Ubuntu one is connected to 135. So let me specify these IP addresses. Group communication 192.168.207.139 and 192.168.207.135, specifying the log path, log Galera arbitrator even log. Now the last, we have to specify the name. Okay, just let me edit one thing. So the name would be Galera arbitrator daemon. That's all. Now we just save this configuration file, and the next step is to run this Galera arbitrator daemon. So Galera arbitrator, detaching it, passing the configuration file, Galera which we had created, Galera arbitrator daemon configuration. So the Galera arbitrator daemon has started. By default, the arbitrator uses the same port as Galera replication engine, and that is 4567. By default, Ubuntu allows all the incoming traffic. If we verify from all the other nodes, we would see that the Galera arbitrator is already configured. So let me verify it by executing the same query. Select from the right set application cluster members. As you can see that this Galera arbitrator is now configured. The idea is, in the production, we need to explicitly enable the required ports via IP tables or the external security group provided by the cloud providers. So first, if we verified that Ubuntu already allows all the incoming traffic, so we can execute this IP tables. We can see that it's all the incoming traffic is allowed. Currently, our Galera arbitrator is configured and being participated in the quorum voting. As I mentioned, even though Galera doesn't store any sort of data, but it still fully participates in the group communication layer, which uses the UDP and TCP traffic on the port 4567. So we enable it with IP table like this. IP table, insert, input, allow the incoming traffic, protocol, TCP, destination port 4567, jump action, accept. So again, we pass the same thing for the UDP by changing the protocol. Now we verified whether they are listing it. So yeah, it's completely listing all the it's completely listing the required traffic ports. But to make sure it survives the reboot and remains persistent, we need to install the IP tables persistent. Apt install IP tables persistent. This makes sure that we don't need to configure the required ports again and again. And then we execute net filter persistent save. So this persists the required port and makes sure that we don't need to configure the required ports again and again on the reboot. Now the idea is we also want to ensure that I shouldn't execute this Galera arbitrator daemon again and again if the instance is restarted or rebooted. I need to make sure that arbitrator starts automatically on the boot. Let's first stop the Galera arbitrator. So I'm stopping it, the Galera arbitrator daemon, also verifying it whether it's stopped or not. So it's completely stopped. Yes, and let me also execute the query from the MySQL. So you can see that the Galera arbitrator is currently unavailable. Now let's create a system daemon service for the arbitrator. So if we create a service, we write a file nano etc system Galera arbitrator service. Okay, by default this file is already created. So if I suppose I would remove this file and all the linkages first. So just give me a minute. Remove this one and remove all the linkages. System B system. Okay, perfect. Now we recreate it and ensure that arbitrator runs automatically on the board. So first we specify the unit, description, Galera arbitrator daemon. Then after network.target wants network.target. Basically, want is just a soft dependency primarily used for triggering. We can also replace this network target with network online target. So the idea is the network target means that the network is on, the network card is on, but the network online target means that the network card is on, it has the IP and it can communicate with the clusters. Although in this scenario, it's completely optional, network target is also fine. Even more, we don't need to specify the wants as well. So also now we specify the service execute start bin Galera Arbitrator daemon, passing the configuration file etc Galera Arbitrator daemon dot configuration, and restart, and again wanted by multi-user dot target. So that is our system daemon file which we had created for making sure that Galera Arbitrator runs automatically on the boot. Let me just save it. And by the way, all of these configurations which I'm doing are pretty much automated in production. It's not manually configured one by one like this. Now, as we have saved it, so the last step is to just reload the daemon. So systemctl daemon reload. And it's reloaded, and then we enable and start the Galera Arbitrator. So systemctl enable now Galera Arbitrator daemon. So it started it. Let me verify or see the status for it. So status, whether it started, just completely started and working fine. Let me also verify from the MySQL query by executing the right set replication cluster members. So we have verified that that our 3-node setup, the 2 DB plus 1 arbitrator, is working perfectly fine. That was all about the split bin problem and all about the installing and configuring the Galera Arbitrator. Thanks.